Alright, I put together a short video to quickly go over some of the notes that we took in class over data distributions. And so in class we were given this foldable, and we went over how to fold it together and cut it apart. Okay, the very back should have this side on it. Okay, if at any time it goes too fast in the video, you can always pause and replay so you kind of know what's going on. And so it should look like this when you get these four panels to describe these different ways of representing data, which we're aware of most of them. Stem and leaf plots. Okay, and that's a way of arranging data by place value. That's two blanks we put there. And so we were able to see that we put the tens place for 72, the 7 here on the stem. And so all these numbers in the 70s, 80s, 90s, and these in the 100s. And so we can identify these numbers that way. Okay, we can also represent data with a dot plot, which I've given you this example. This displays data represented by a dot above a number line. Okay, so the very first number in this data set would be the number 8, then the number 9, and then 10, 10, and 10, because there are 3 10s, and then 11, 11, and then 12, 12, 12. And so this is a good way for us to visualize what the mode might be, because you can see what the greatest number of occurrences are for each number. And so this is would have 2 modes, 10 and 12. Okay, and so we've seen those. These 2 new ones at the bottom are a little bit new to us. If you were in class, then you need this explanation. So we've looked at box plots first. And I'm going to zoom in a little bit so that it's a little bit easier to see. All right. And in a box plot, this is a way to display how data is distributed. Okay, these are both ways to display how data is distributed. And we actually call these box and whisker plots. And the box plot actually represents the IQR. The box part of it represents the inner quartile range, because this left edge is the first quartile, or lower quartile, Q1. And then the right edge of the box is Q3, the third quartile. And then somewhere in between the 2 quartiles we would find the median. It is not always going to be exactly in the middle of the box. It just depends on how the numbers work out. But the number line, you'll notice, is either spaced out by 2s, or a lot of times we count by 1s, or any other way of counting as long as they're in even increments, or equal increments, I'm sorry. So in this case, we can see the IQR goes from 12 back to 4, which is an inner quartile range of 8. But then the whiskers of a box plot go out to the minimum on the left and the maximum on the right. And again, minimum and maximum are least value and greatest value. You can find those in the calculator. They're right. The minimum is right before Q1 when you bring up those one variable stats, and the maximum is right after Q3. And so they actually appear in order: minimum, Q1, median, Q3, and max. And those 5 data points help us make box plots. All right? But then another way of organizing data by its distribution is a bar graph that shows that distribution in equal intervals, and that is called a histogram. A histogram organizes the information in bars, but by equal interval ranges. Okay, so we might have numbers 8 through 16, where some of them are 8, 9, or 10, others are 11, 12, and 13, and others are 14, 15, or 16. And coming up with the intervals a lot of times depends on how many, what the range of data is. But make sure you want to include the minimum value. Okay, we want to go from minimum to maximum, including both. All right, and that's going to help us set up those intervals. And so we did some practice work in class on how to set those intervals up. If you were gone, you might need some extra examples on how to set up box plots and histograms. Again, these are histograms. These are box plots. And then we also looked at how to describe the distribution of that data using the next graphic organizer. Okay, and so we looked at these data distributions, and the first one we looked at was a symmetric or bell-shaped distribution, and that's any time that the data, when it's organized in either a histogram or a dot plot or even the box and whisker plot, when it looks very symmetric. That means data that is symmetrical, you should be able to read this, if it's bell-shaped, has its highest point in the center, meaning the most number of data points occur in the middle, and then it's a mirror image of the left and right on either side, and so it kind of just fades off down towards less points on the left and the right, and it is even on both sides. And so that's a symmetric bell-shaped distribution. But if we were to shift this data one way or the other, we call that being skewed. And so the first one we looked at was if it's skewed right. And if the data is skewed right, here's what that means. That there are fewer data points on the right. So if there's fewer, you can remember that few and skew rhyme. So if it is fewer on the right, it is skewed right. Okay? So anytime we look at this, we understand that it is skewed to the right. And you can see that our example from a box plot, when that right whisker, the maximum is so much larger than the quartiles here, that means it's skewed right. Okay? Now we also looked at grade distribution as an example here. Let's pretend that these were grades, where these are F's, D's, C's, B's, and A's. In a symmetric distribution, this is kind of what we expect to happen most of the time with grades, that the most grades are in the C range. And then we've got fewer D's and F's and fewer B's and A's. And so this is kind of a good idea or ideal distribution of what grades might be. But if we look at if it's skewed right, that would mean there are more F's and D's than any of the rest. And unfortunately, this is what happens a lot of times, maybe in an Algebra 1 class, where we get a lot of struggling students here. And so we want to work away from that. We want our data to be more like this than we do this if we're talking about grades. And this could be anything. But then if we look at the other option, that it's skewed to the left, sorry, this was skewed right, this is skewed left, and there are fewer data points on the left, looks like this. Now, if this was grade distribution, there may only be one F, two D's, and then we have a lot more C's, B's, and even the most A's. Now, if these are grades, there's a good possibility that maybe things are a little bit too easy. And it's a little bit too easy to get a B or an A. And so this is kind of some of the things that we think about as teachers. And so you get the idea of a histogram dot plot or a box plot for these different distributions. Again, this is symmetric, skewed right because there are fewer on the right, and skewed left because there are fewer on the left. And we do have a fourth option, which we don't see a lot, but that would be called a U-shaped distribution. And this is symmetric still because it's the same on the left and right, but it's the exact opposite of what we would normally expect, where the fewest data are in the middle, and then it's an equal mirror image on both parts. And so we have even more data points here. I can't really explain it the same way I did with grades here, but it would look like this. And this would be a little bit strange, where either we have a lot of D's and F's and a lot of A's and B's, but nothing in the middle, no C's. That's kind of what it might look like for grades. Okay? And so in our distributions, in these three, you will have to excuse the bells because we're testing them for some reason. But in these three, if it's symmetric, the mean is typically the best measure of center. The best way of describing the center of the data would be the mean, or the average, if it's symmetric. But if it's not symmetric, if it's skewed right or skewed left, then the median is the best measure of center. Okay, and so that's kind of what we went through in class. So this helps you understand what to fill in or what to have identified through these graphic organizers when we talked about this information.